Hello and welcome back to my channel. So today we are going to talk a little bit more about concurrency, and in the previous video we spoke just about the vocabulary that's used because there is new, runnable, waiting, timed waiting, terminated and blocked, and there's also the wait, await and everything with synchronization as well. So today we're going to do an example. Thank you so much for those people that have subscribed so far. Please do like, share and subscribe so I know to continue with more. I know the previous videos, this week it's Irish week, so I've been posting up some of the vlogs about languages as well. Programming languages are not excluded from being a language. They take practice and time and effort, and yeah, anyway. So now we're going to look at concurrency in an example, because we know from concurrency, we know as well that we want to run different threads at different times. So an operating system, Java's runnable state has two separate states. So the operating system hides these states from the Java virtual machine, which sees only the runnable state. So here we have, hold on, new computer, please bear with me and be patient. So here we've got an example where we're using, in the print task, we're just using a secure random number. And again, we initialize a new object of secure random. We've got a new int and a task name, constructor, print task with so the default constructor is empty. We know that we don't need to type out the default constructor unless we want to change it or anything. You can check out the constructors video if you're unsure about this. But here we have print task, string, task name. So anytime that we call print task, we need to pass in through a string. This task name then is going to be, because it's a public constructor and these are private instance variables, again with concepts of encapsulation, etc. Please check out those videos if you're unsure about it, about this keyword as well. So we have task name. It's now going to be assigned to the task name in the class-wide variable task name. Then we have sleep time, which is going to be assigned whatever next integer here. So we have our returns a pseudo random uniformly distributed int between the values of inclusive and the specified value exclusive drawn. So that's our sleep time. Then we have our override methods. If you want to ever check where your override methods are, you go usually within Eclipse, you have source and you can go override implement methods. And because I have already implemented it, it's not listed here, but if it wasn't, there would be more. There would be the run implement method that you just tick the box and it will produce the override public void run as a generated method stub. Then I've just added in a try and catch statement for the example. Here we just print out the milliseconds with the task name and the sleep time, and thread being part of java.lang.thread. It's not part of the concurrency package. So if we look at thread is a thread of execution in a program, the Java virtual machine allows an application to have multiple threads of execution running concurrently. So even though it's part of concurrency where you can run multiple threads at the same time, it says here like every thread has a priority. Threads with higher priority are executed, blah blah blah. You can read this in your own time. I'm going to skip now to the task executor because this is where the package java.util concurrent comes into play. And we just use two different classes. So an executor that provides methods to manage termination and methods that can produce a future for tracking progress of one or more asynchronous tasks. And then the other one, executors, so factory and utility methods. If you're unsure about utility methods, please check out my earlier videos. I talk a little bit about them when I'm talking about methods in the very, 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 very beginning videos. So factory and utility methods for executor, executor service, scheduled, executor service, thread factory, and callable. So methods to basically look at configuration. So we need to use these both together. So here we just, again, initiate a new object, call it task 1, pass, we can call this whatever we want. We're going to say task 1, task 2, and task 3 because that's referring to this object task 1, 2, and 3. Then we use our new cached thread pool, which creates a thread pool that creates new threads as needed. But we'll reuse previously constructed threads when they are available. Here then we pass through our objects to execute as a runnable command, execute task 1, 2, and 3, and then we shut down the service. Every time you initiate a service, usually you have to stop the service within a program. Makes sense, totally logical. So we have to shut it down and then we print it. So when we run the program, we get the following console output. So this also depends. Task 1 done sleeping, 3 done sleeping, 2 done sleeping. So if I run it again, it's in different orders. 3, 1, 2. So you can see as well main ends. So at the operating system level, then we have the operating system hides these states from the Java virtual machine, which sees only the runnable state, which we spoke a little bit in the previous video about. So, and I think I used the traffic light example, but anyway, when a thread first transitions to the runnable state from the new state, it's in the ready state. So new to runnable, now it's ready. A ready thread enters the running state, so it begins executing when the operating system assigns it to a processor. So this is also known as dispatching the thread. So for those of you interested in history and stuff, you've got the dispatches. But anyway, in most operating systems, each thread is given a small amount of processor time called quantum or time slice. Usually with time slicing, it's like setting sections to expire or to be in the ready state, so with which to perform its task. So deciding how large the timeline or quantum should be is a key topic for operating systems to make them run efficiently. We want to use as much of the time in the operating system as possible, make sure everything's in a good state. So when it's quantum, it expires. So when the time slice expires, then the thread returns to the ready state and the operating system knows another thread is ready, so it's available to go to the next state. So transitions between ready and running are handled by the operating system. Ready, run, ready, run, ready, set, go. For those of you who played outside when you were younger, it was ready, set, go. So the Java virtual machine does not see the transitions. It simply views the thread as being runnable and leaves it to the operating system to transition the thread between ready and running. So the operating system always is in control of when it goes ready, running, ready, running. And that's up to the operating system. That's why it's important to have a good operating system, you know. So the process that an operating system uses to determine which thread to dispatch is called thread scheduling. So if you picture it like a person who's sitting on a chair and they're doing all the operations, and you have other people and one is ready and then one is already on a treadmill running over there. And so okay, now they've finished. Now they go back to the running state. Now the ready person goes back on the treadmill. So it's almost like a person sitting at a desk and going, okay, they're ready. You can go on the running state now. Okay, and they have to look after the scheduling. That is the job of the operating system. So the operating system's view of the running state. Person, let's say there's, for example purposes, there's two people. One is ready and one is running. So one is on a treadmill over here. That person then gets off the treadmill and goes to sit down, and then they're ready and they go into the ready state. And then the other ready person goes back on the treadmill. That's how it goes. So every thread then has a priority, and that's also important. So we've got scheduling, priorities, ready, running, dispatching the thread, time slices, and thread scheduling. So thread scheduling, again, thread scheduling, ready and running, ready, run, ready. And then we have dispatching the thread because when the operating system assigns it to a processor, okay, I'm going to dispatch you over here now to run. So the thread priorities and thread scheduling then. So there's informally there's higher priority threads that are more important to a program and should be allocated processor to than lower. But so we've got thread priorities cannot guarantee the order in which it executes. So this is why I ran the program again, because you can see that it changes every time. So an operating system's thread scheduler determines which thread runs next even. So one simple thread scheduler implementation keeps the higher priority thread running at all times. And I spoke about round robin. This is where it comes into play. I'm so excited. So if there's more than one highest priority thread, ensures that all threads execute for a quantum or time slice, each in round robin fashion, which we'll talk about more in the next video. I want to keep these short and sweet. There's a lot of new vocabulary that we just covered again. So ready, running, the operating system dispatches a thread, there's time slices, and it's all within runnable. So it implements runnable here. So this is our interface, runnable. It should be implemented in the class whose instances are intended to be executed as a thread. And that is why we can go to source and override methods. And you'll see normally, if I hadn't implemented it already, the run method, and it generates the method stub for it here, but it's because it's already there, it's not on the pop-up. Anyway, you get the idea. So then we have our executor and our executor service, and for every service that we start we have to finish it. We have our threads that are produced here, and next week I will pick up exactly from this program. I'll post it up on GitHub as well. You can check out the code there. Thank you so much for watching my videos. I'm so excited. Thank you. And also please spread the word for people that are watching it, because then I know to make more. Okay, thank you so much, and take care. Stay safe. Thanks for watching. Thank you for subscribing, and see you next week. Bye.